During this segment, we will be simplifying algebraic expressions. Let's begin by reviewing some vocabulary terms and phrases. First, these are algebraic expressions, or sometimes we just call them expressions. Remember, an algebraic expression or an expression is a combination of numbers, letters, and arithmetic operations. So this is an expression, this is an expression, and this is an expression. The add-ins of the expression are the terms of the expression. So this algebraic expression has one term. This algebraic expression has 1, 2, 3 terms. And then let's look at this algebraic expression. Notice this term happens to be a number only. A special term that is simply a number is given a special name called a constant or a constant term. So this happens to be what we call a constant or a constant term. Also, I'd like to talk about, let's just look at this term, 6m. Remember, this means 6 times m. We call the numerical factor of a term the numerical coefficient, or sometimes simply the coefficient. So the coefficient of this term, or the numerical coefficient, is 6. The numerical coefficient of this term is 4. The numerical coefficient of this term is 3. The coefficient here is 4. And this is a constant, the constant -7. This is also, by the way, called a variable term. So this is a variable term because it does contain a variable, and we normally use letters for variables. So this is a variable term, constant, variable term, constant. So there's a little bit about algebraic expressions. We're going to use the distributive property to help us add like terms. These happen to be like terms. So let's talk about what we mean by like terms. Terms are like terms if the variable parts are exactly the same and they only differ by, at most, their numerical coefficients. So notice this is m, this is m. The variable portion is exactly the same in these two terms. The numerical coefficients are different. They can be the same or can be different. So these are what we call like terms. Terms that are not like terms are unlike terms. For example, these two terms are unlike terms because the variable portions are not exactly alike. Now, let's review that distributive property for just a moment. We used to say that, for example, A times B plus C is equal to A times B plus A times C. A times B plus A times C. But notice you can also read this from right to left. And that's what we'll look at right now. Let's look at that portion of the distributive property. If A, B, and C are numbers, then A times C plus B times C is equal to, in parentheses, A plus B times C, and also AC minus BC is equal to, in parentheses, A minus B times C. So let's use the distributive property in that manner to combine these like terms. Now notice these are like terms, so by that portion of the distributive property that we looked at, we can say that this is equal to 3 plus 5 times x. Notice this is x times 3 or 3x plus x times 5 or 5x. So I'm just using the distributive property in a different manner. So I have 3 plus 5 times x, 3 plus 5 is 8, and 8 times x is simply 8x. I have simplified this expression by combining like terms, and that's what we will concentrate on. Let's do that again. Let's look at another expression. Suppose we have 3a plus 2a plus 7a minus 5. There is my algebraic expression, also called my expression. Notice these first three terms are like terms, so let's combine these like terms. This is equal to, now it's up to you, let's see if we can go ahead and do this mentally. 3a plus 2a is 3 plus 2 or 5a, and then 5a plus 7a is 5 plus 7 or 12a. So 3a plus 2a plus 7a, that's 12a minus 5. Can we simplify any further? The answer is no, because these are unlike terms and we cannot combine unlike terms. Now notice this is a variable term and this is what we call a constant. But here we have this expression simplified. Let's try that again. Let's look at another expression. Let's suppose we have 6x minus 4 plus 2x, my variable will be x, plus 2x minus x plus 3. Here is my expression. I want to know if this can be simplified by combining any like terms. Well, notice I do have some like terms. Those are like terms, and of course I can combine constants also. So let's use the commutative property. Don't forget, with addition, the commutative property says that we can change order and the sum remains the same. So let's first of all take a moment and let's write this as a sum. That's 6x plus negative 4 plus 2x plus negative x plus 3. And then it might make you more comfortable as I change the order of these terms, having written this as addition. So I'll write 6x, and next to that, I'll write the like term 2x, and then next to that, I'll write the like term negative x, and then just don't lose any terms here. There I go. I've changed the order, but we can do that when adding. That's the commutative property of addition. So now let's see what we have. 6x plus 2x, that's 8x. Now this negative x, if you'd like, if it helps you, think of it as, and I'm going to write it down so you can see it. Think of it as negative 1x, because that is the same as negative x. So 6x plus 2x, that's 8x. Then 8x minus 1x, that is 7x. So I have 7x. And then what do we have for negative 4 plus 3? Negative 4 plus 3 is negative 1. So you can write it as this, or you can write it as 7x minus 1. Either way is okay. Just remember, we can go no further because those are unlike terms. Simplified then, this simplifies to 7x minus 1.